Welcome, check solution. This is modulus inequality using graphical method. So this is part 2. Alright, so if you haven't watched part 1, I encourage you to go and look for part 1 here. So let's go here. So we have this one: solve the inequality modulus of 2x plus 2 greater than 1 minus 4x here. So in this lesson we are going to solve this one using the graphical method, and later on I will just solve using the algebra method here. So let's go here. So we can consider the graph of y is equals to modulus of 2x plus 2. Alright, and also consider the graph of y is equals to 1 minus 4x here. Alright, so let's first consider the graph of y equals to modulus of 2x plus 2 here. So we can consider a straight line of y equals to 2x plus 2 here. So when x equals to 0, we are finding the intercept. When x equals to 0, y equals to 2. Then when y equals to 0, x is equals to minus 1 here. Alright, so then we go to the x-axis here and the y-axis. Then we are plotting our intercept. The graph is cutting the y-axis at y equals to 2, and the x-axis at x is equals to minus 1. So these are the points that we have here, 2 and minus 1 here. Then we draw our line. So you can see below the x-axis here, I put a dotted line here because of the modular sign here. So which means the negative side will be reflected to the positive side here. Alright, so we are going to reflect this negative side to the positive side. So this is the graph of modulus of 2x plus 2 here. So this line here, continuing from this part, this side here is going to be y equals to 2x plus 2. And the reflected part here is y is equals to minus open brackets 2x plus 2 here, the reflected part. Then the combination of these two graphs here combined together will give us the graph of y equals to modulus of 2x plus 2 here. Alright, so now we are considering the graph of y equals to 1 minus 4x here. So when x equals to 0, y equals to 1. Then when y equals to 0, x equals to half here. Alright, then we go on the x-axis and y-axis here. Then we plot our points. We have 1 and a quarter here. Alright, so then we draw our line here. Alright, so one of the things that you need to be very careful when you are plotting these things, you can try to use a certain scale or try to make your graphs to be proportional such that you can actually see where the graphs are intersecting. Because if you look closely here, you can see this line here is a gradient of -4 here, and this one is a gradient of 2 here. So you can see -4 here and gradient of 2 here. So if you go to the other side, you can see the graphs will not intersect here. All right, so be careful when you are dealing with this kind of thing here. So let's now go here and see how it looks like here. So our critical point here in this case is at this point here. This is our critical point. So we need to find this critical point. So this critical point is a point of intersection of this graph of y equals to 2x plus 2 and y equals to 1 minus 4x here. Alright, so let's intersect here. So 2x plus 2 is equals to 1 minus 4x. Alright, then what are we going to have? We are going to have x is equals to minus 1 over 6. That's the point here. Alright, so now if you try to interpret this inequality here, they're saying modulus of 2x plus 2 is greater than 1 minus 4x here. So we need the position where the graph of modulus of 2x plus 2 is above the graph of 1 minus 4x here. Alright, so the region here, you can see starting from this point, this blue graph here will be above this graph here. So going from this point going to the right side here, we're going to see that this graph will be greater than the graph of y is equals to 1 minus 4x here. So therefore the set of solution will be x greater than minus 1 over 6 here. That will be the solution for this one. Alright, so we want to solve this equation, this inequality here, using the algebra method again. Alright, so let's go here. Solve the inequality 2x plus 2, modulus of 2x plus 2 greater than 1 minus 4x, which is the previous question here. Alright, so as usual here, when you are solving here, we said the first thing is to find the critical values by solving the corresponding modulus equation here. So the corresponding modulus equation is modulus of 2x plus 2 is equals to 1 minus 4x here. Alright, so this will translate to 2x plus 2 is equals to plus or minus 1 minus 4x here. So we are going to have 2x plus 2 is equals to 1 minus 4x here. Then we are going to have here will give us x is equals to minus 1 over 6 by solving for x here. Then the other one here, if you put a 9 minus, take 1 with a minus here, we are going to have 2x plus 2 is equals to minus 1 plus 4x here. Put a minus here, so it becomes minus 1 plus 4x here. So this becomes x equals to 3 over 2. So the next thing now is to put these critical values on the boundaries here. Alright, so you can see we have x less than minus 1 over 6 as the lower boundary. Then the next boundary here will be minus 1 over 6 less than x less than 3 over 2. Then the last one here will be x greater than 3 over 2. So now what we need to do is to test these boundaries here to see which is the true region here and the false one. So we are taking the true one. Alright, so if you have been watching videos on inequalities, I know you are now well vested with this method here. Alright, so we are testing using the original inequality here. So we are testing for true region. So we are testing for x less than minus 1 over 6 here. This is our first boundary here. So we need to use any number which is less than minus 1 over 6. We can use x is equals to minus 1. Then we put minus 1 into this one. We are going to have 0 is greater than 5 here. Modulus of 0 is greater than 5. So which means is 0 greater than 5 here. So 0 is greater than 5 is a false statement. So which will make this one to be false. This region to be false. Then we test for the next region here, which is minus 1 over 6 less than x less than 3 over 2 here. So we need a number between minus 1 over 6 to 3 over 2. So that number is, we can take 0 here. The number between here, we can take 0 or we can take 1. So in this case, we are using 0. So if we put 0 here, we are going to have modulus of 2 is greater than 1 here. So this will give us 2 is greater than 1. So which makes it to be true. So this statement is true. So which make this one region to be true. So the region of minus 1 over 6 less than x less than 3 over 2 is also a one-way region here. Alright, then we go to the next one, testing for a region which is greater than 3 over 2. So we use x is equals to 2 here. A number which is greater than 3 over 2 here, so we use 2. Alright, so if we substitute 2 into that inequality, we are going to have modulus of 6 is greater than minus 7 here. So which is going to give us 6 is greater than minus 7. So 6 is greater than minus 7 is a true statement. So which makes this region to be true. So now you can see we have false, true, and true here. So which means starting from this boundary going to the right side here, starting from minus 1 over 6 going to the upper side here, it means the solution is valid. So therefore the set of solution is going to be x greater than minus 1 over 6 here, because we are taking from this part here going to this side. So x greater than minus 1 over 6 going to this side is true here. So that will be the solution. Right, so thank you for watching the video. See you in the next lesson.